Let's have a look now at how the basic smoke shader works. So let's move into the shop context and dive down into the smoke shader. And we can see that we've got a number of parameters here. These are the boxes coloured yellow. But in fact, not all of them are parameters which appear in the parameter editor of the shader. If we bring up that parameter editor, we can see that we've got a fairly limited number of parameters. But in fact, two of these, one of them the color, the other the density, are marked as invisible. And that means that they don't appear in the parameter editor, and that the shader is going to try and look for these values as attributes of the primitives it's shading. In other words, it's going to try to extract the values from the volumes that it is shading. And density is the thickness of the fog, and the CD attribute is color, and that has 3 values. So if we wanted properly colored fog, we would need to shade 4 volume primitives occupying the same space. One of the primitives would have the density value in it. The other 3 volume primitives would have the 3 components of color: cd.x, cd.y, and cd.z. Now, the meat of the shader is happening inside this subnetwork here, if density not 0. And this is only executed if the density is greater than 0. Let's dive inside and see what it's doing. Well, there are 2 real parts to this, one of which is an illuminance loop, which is calculating the lighting on our fog, and the other one is this calculate opacity subnet. And it's this calculate opacity subnet which uses the depth of the microvoxel, and here it is, it's called dp/dz, to work out the opacity. And I'm not going to go into detail about how that happens, but you would need a setup more or less like this in any successful volume shader. So essentially what's happening is that our density is multiplied by our illuminance and our opacity to produce the color output, and the opacity is fed into the opacity output, and these then are fed into the final output. So let's, as a final task, create some multicolored smoke. And to do that, I'm going to need to set up some color information here in my network. So I'm going to get rid of the volume VOP, and we've got our sphere multiplied by our noise, and we're going to use this for the density. So let's rename this density, which we can do using a name sop, and I'm going to rename it density. And now we're going to need something to produce colors. Now we could use the technique we showed using the volume ramp sop, but I'm going to use a slightly different one. I'm going to create an ISO surface, bring up a parameter editor, and I'm going to make it a noise function, except I'm going to add an offset to each of the values so that they're different from the ones we've got here in the sphere. And let's Control-C, Control-V to produce another one of those, and Control-C, Control-V to produce a third one. And in each case I'm going to need to change the offset values so that they're different for each of these. And do the same for the last one. Like so. So we should get 3 different noise functions, and we can then merge these together, like so, to create a 3-valued, or 3 volumes with 3 values. And I've made a mistake here. These need obviously to be volumes. So yep, we now have 3 volumes, and then I need to rename these, and I need 3 renamings, 1 for each. So primitive 0 we're going to call cd.x, primitive 1 we're going to call cd.y, and primitive 2 we're going to call cd.z, and that should produce our 3 colors. And then we need a final merge, which will bring our color information and our density information together. And we put the display flag on that. And let's move back up here, and let's have a look at a render. And we can see, though it's not terribly clear, that we are getting multi-colored spherical noise. I'm going to interrupt this and just apply the same thing to just the sphere, and I can do that by taking out this input here and inputting this directly into our name, and let's re-render. And we're getting a coloured spherical bit of fog. I'll pause the video while that renders finally. And there it is, our multicoloured spherical fog or smoke. One final remark before we leave this topic of volumes, which is that we can create volumes directly using metaballs. So if I create a metaball here, let's just turn off the display of our geometry. If I create a metaball here, or a group of metaballs, we can, on our geometry node, in the render tab and the geometry sub-tab, select this option here, render metaballs as volume. And the result of this will be that our normal metaball will be rounded as a volume primitive. And obviously, if that's going to happen, we need to assign a smoke shader to it, and we can see whether we get a result, and we can see that that is shaded as a smoke primitive. And this could be very useful for creating objects like clouds, because you can copy metaballs onto points and then use them as the basis for some shading which creates some cloud-like effects. So that brings us to the end of this introduction to volumes in Houdini. I hope it's been useful.